If there's one thing we can all agree upon, it's that we need to build our capacity to solve problems together. Collabyrinth is an experiential education platform that is part game, part science lab, and part design activity that helps build this capacity in students ages 14 and older. It simultaneously provides a structure for autonomous learning where the requirement of social skill development is built into the game. The Collabyrinth hardware is designed so that each player only controls one tilt axis of a maze. The tilt controls provide the means to maneuver a ball on the surface of the maze. Each maze surface is comprised of a series of challenges that require the players to work together for success. The problems on the maze surfaces get more difficult, and the level of player harmony required to complete the challenges increases over the course of a maze. From the game standpoint, the objective is to maneuver the ball from the start of the maze to the central hole. In order to achieve this outcome, however, players must become aware of their emotions, communicate with their partners, and execute agreed-upon strategies reproducibly. There are three curricular elements to Collabyrinth that prompt the development of students in different ways. First, Collabyrinth is a game that creates social connections, improves emotional awareness and control, and builds students' capacities for solving problems together through strategy and communication. Students' immediate experience of the exercise is that it can be frustrating to share equal stake in a problem-solving venture. Each pair of players has to come to a common vision for how to address each section of the maze, and all sorts of undeveloped approaches to problem-solving are immediately brought to the surface, including blaming the partner for errors, seeking shortcuts to success, and avoiding the effort required to communicate, plan, and practice. The game gives real-time feedback on these behaviors, and to have any success, students will overcome these shortfalls incrementally. When using Collabyrinth for social connections, an instructor can employ reflective surveys, videography of student play, and think, pair, share check-ins among many other modes to get students thinking about what it will take for them to work with their partners to solve ever more difficult problems. The great part is that the evaluation of student development comes from the game itself. Collabyrinth tells its players when they're getting things right. The better a pair of players works together, the farther into the maze they will get. Collabyrinth provides a means to practice behavior rather than simply talk about behavior. In the second mode of learning, Collabyrinth acts as a human performance laboratory. Both quantitative and qualitative metrics can be measured during play, and students can design experiments, develop and test hypotheses, and collect and analyze data, all of which is directly related to them. This keeps the motivation for learning high. As a sample experiment that can be performed by grade 10 students, randomly selected pairs of students play a maze that is structured for data collection. It has identified stages on its surface, so students can determine with a number how far they got through the maze on a given trial. Each trial of the maze over 15 minutes has its duration and highest stage achieved recorded. After 15 minutes, the pairings of students are changed, and another 15-minute session takes place, generating a new data set. The data is then compiled on a spreadsheet by students, and some elementary relationships are examined. Students can be asked what they think the relationship between duration of play should be as a pair of students makes more attempts during a 15-minute session. Their expectations can be plotted by hand and then compared to plots generated on the spreadsheet. Students can be asked how an assessment of collaborative performance might be extracted from the datasets, and tasked with getting the spreadsheet to do the required calculations and graph generation. Here again, students are examining data related to their own performance, so there is an authentic connection between what they are analyzing and their own development. In the third learning mode, students are tasked with the design, building, testing, evaluation, and rebuilding of their own maze. This series of problems fits well in any classes related to creativity, art, industrial arts, ADST, and design engineering classes. Once students have played Collabyrinth, they will know all of the constraints required to build a maze. This creative aspect of Collabyrinth begins with students designing a maze in the abstract. Pencil and paper or computer-aided design software can be used. The idea is to get students to try to have their maze intentionally designed to lead a pair of players through a narrative. When it comes to building mazes, the DIY maze blanks provide a substrate that can easily be worked with hand tools or small power tools and is compatible with all adhesives. Recycled items can be used for rails, walls, obstacles, and ramps, and the sky's the limit in terms of what kinds of challenges a maze will present. Students can design and 3D print maze elements that are difficult to build otherwise, or that have mechanical motion requirements. Maze designs and builds are acts of creativity, but true design requires testing to see if the problem has been addressed. During the build phases, students can test portions of their maze and tune the structures for difficulty. Once a maze is complete and it has been solved reproducibly by the designer, students can share mazes and evaluate them according to a rubric that is also designed by students. In building a rubric, students will need to agree upon the definitions of some rather subjective ideas, like fun, challenging, and entertaining. Once the evaluations are complete, each builder needs to take the feedback from their peers and make changes to their maze to appeal to the ideas of how the maze can be improved. Because each step of the design, build, and test process involves creating an object of entertainment, motivation levels are sustained, and a sense of aesthetic competition for the best maze helps keep students going. The three facets of Collabyrinth, collaboration and social emotional learning, data collection and analysis, and design, build, test, can be explored at different depths, ranging from 1-hour sessions to significant segments of a course. They can also be revisited year after year as student capacities for deeper thinking, social bonding, and inquiry-based learning are elevated. The Educator's Guide to Collabyrinth gives teachers a comprehensive direction to the use of the hardware, including the pedagogical underpinnings of the learning platform, sample lesson workflows, student experience notes, learning strategies, and extension opportunities. It also identifies the elements of BC's core curriculum that are directly enacted during a particular learning activity, and provides a suggested hour-by-hour schedule to introduce each of the three elements. The guide contains all that is needed to get a teacher up and running with Collabyrinth as an open-ended, multidisciplinary learning platform, and teachers with different interests can pick and choose what paths their students explore. If you want to see your kids connect over a non-competitive game, learn about themselves by measuring and improving behaviors, and express their problem-solving abilities creatively, check out the links below for more information. Thanks for watching.